Next up in the volume unit is how to find the volume of a sphere. Alright, so as we know, a sphere is a three-dimensional solid, and the radius of a sphere is actually, for most spheres, especially if you can't see through the sphere, like a basketball or something, you can't see the radius because it starts in the very, very middle of the three-dimensional solid and goes out to the edge. But what you're going to do for that is, for the volume of this guy, is you're going to take that radius, multiply it by itself 3 times, so r to the third power, times pi times this fraction 4/3. Pretty complicated formula, but it's one of those things where if you know the radius, that's really the only thing that you need to find, so it's not too bad. Number 1. In this case, I'm giving you the radius of the sphere and asking you for the volume. So this is the most basic example. 4/3 times pi times 19 to the third power. So the radius would be like that. So let's see, we got to go to our calculators here. Pretty big number, 28,730. And volume again is a cubic measurement, and what that means is if you were to fill this up with air or fill this up with water or something, that's how much stuff would go inside of the sphere. Remember, volume is talking about how much space is inside our 3D solid. Number 2, we have let's see, a collection of spheres. Find the total volume of this pyramid of identical spheres. So they're all the same. All the spheres are the same. So what I'm going to do is maybe draw one of them. When we draw spheres, we tend to draw them like this. And what I'm looking at here is that the distance from here all the way over to here is 30. That's a 30 centimeter distance right there. So 30 centimeters is the distance from 1, 2, 3, 4, 5 spheres. Well, that means that 30 over 5, each one of them is 6 centimeters in diameter, which means the radius is 3. So if we find the volume of one of these, we just go 4/3 times pi times 3 to the third. So we go 4/3 times pi times 3 to the third is 113.097. That's cubic centimeters. So that would be like the volume of one of these things, if we were to highlight that. Alright, just one of them. But it's asking for the total volume, so we need to know how many there are in all together. So let's think about this for a second. We've got 1, 2, 3, 4, 5. I'm just going to go along the base first. We're going to call this, level A, level B, level C, D, A, B, C, D, and E. So in level A has how many spheres in it? Let's think. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That looks like 25 spheres. Level B has, let's see, 1, 2, 3, 4. 1, 2, 3, 4. That looks like 16 spheres. Level C has 9. 3 times 3. Level D has 1, 2, 3, 4. And of course, there's only 1 at the top. Level E has just 1. So we have all together, let's see, 25 plus 16. Well, 16 and 9 is 25, so it's 55 spheres. So we want to take our volume of one sphere and multiply that by 55. That'll get you your final answer, which is total volume 6,220.353 cubic centimeters. Last one. Alright, so we have, let's see, talking about the game of pool here. Standard billiard ball is 2.25 inches wide, so that's a diameter. Alright, that would be this distance right here. 2.25 inches. Alright, so the radius would be half of that. So what's half of 2.25? Well, that would be 1.125. And that's true over here as well. Alright, so let's keep going. It's made of very dense material. The material that each ball is made of weighs about an ounce every cubic inch. Okay, what's the difference in total weight of the racks of this game, which is called 9-ball, and this game, which is called 8-ball? And we're talking, what's the difference in weight? Alright, so first of all, let's find the total volume of this rack. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of those things, so let's multiply 9 times the volume of one of them. The volume of one of those billiard balls is 4/3 pi r to the third power. The radius we just said was 1.125. So what I'm going to do is take 9 times 4/3 times pi times 1.125 to the third. Alright, and that is the total volume of a rack in 9-ball. And the weight of this thing, if it's 53.677 cubic inches, we already said that the material of each ball weighs about an ounce for every cubic inch. So that means it's about 53.677 ounces. Alright, if we're thinking about that in pounds, I think there are 16 ounces in a pound, so that's about 3.35 pounds. Over here, total volume for this rack of billiard balls, how many are there? Let's see. Let's count these up. I'll go with a green. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So there are 15 billiard balls in a rack of the game called 8-ball, and it's 4/3 times pi times 1.125 cubed. So you just type that in and see what you get. Looks like I get 89. This is volume, 89.462 cubic inches. So that's volume. Each cubic inch weighs about an ounce, so the same in ounces. And again, if we're thinking about pounds, it's about 5.6 pounds. So the question's asking for the difference in the total weight. Difference is subtraction, so just take those two and subtract them. So it's 89.462 minus 53.677. You get about 35 ounces, 35.8 ounces. So that means that the rack on the right weighs that many more ounces than the rack on the left. And again, if we're thinking of that in pounds, it's about 2 pounds, a little over 2 pounds.